Hello students, I am teacher Thaddeus Baluka, your chemistry mentor. Welcome back to my channel. Remember to subscribe. In our today's video, I'm going to navigate the topic of nitrogen and its compounds. We are in the subtopic of ammonia. Specifically, we are dealing with laboratory preparation of ammonia gas. So we look at the lesson objectives. By the end of the lesson today, you should be able to describe the laboratory preparation of ammonia, describe the chemical test for ammonia gas, and state the physical properties of ammonia gas. So we'll start by looking at laboratory preparation of ammonia. And ammonia is prepared in the laboratory by heating a mixture of any ammonium salt with a base. So you are heating a mixture of ammonium salt plus a base. Normally, usually we have the use of either potassium hydroxide, sodium hydroxide, or calcium hydroxide. But we preferably use calcium hydroxide and ammonium chloride. They are the most commonly used reagents because they are abundant, they are cheap. So let's look at the reaction that takes place there. So we are looking at the reaction that takes place here, and we're having calcium hydroxide reacting with ammonium chloride to form ammonia plus water plus calcium chloride. So if you react any of those two salts, you're going to find that if you are using the base is calcium hydroxide and you are reacting with calcium chloride, then automatically you are reacting with ammonium chloride, you're going to get calcium chloride plus ammonia plus water. So the corresponding salt produced here will depend on the ammonium salt used. So if we change the base, we can also use a different base like sodium hydroxide plus ammonium sulfate. So the sulfate ion from the ammonium salt will combine with the cation of the base, that is sodium, to form sodium sulfate. The other products are ammonia, gas, and water. Remember, we are using dry reagents. The reagents must be dry because ammonia is highly soluble in water, and in case they are moist, then the ammonia gas produced will dissolve in the moisture rather than the few drops of water present in the reagent. So the reagents must be dry. In this kind of a scenario, we are looking at now the laboratory preparation. We have the diagram here, and we're having the reagent here. We're having dry ammonium chloride and calcium hydroxide. They are being heated in a round bottom flask. You can see the orientation of the flask. It is slanting downwards. The round bottomed flask is slanting downwards. This is to prevent, remember, the reaction from the previous slide. You can be able to see the reaction between calcium hydroxide and ammonium chloride produces water. So if the water is formed here, it can flow back to the flask and cause the flask to break. So that is why the flask should be placed in such a manner that it is slanting downward. Remember, in some of the books, they talk about the flask should be slanting. There is nothing called slanting. You should be able to give out the direction. The flask is slanting downwards. Then we are able to have the drying tower. The ammonia is only dried using calcium oxide. It cannot be dried using calcium hydroxide, calcium chloride, or concentrated sulfuric acid. So the only drying agent here is calcium oxide. Anhydrous calcium chloride and concentrated sulfuric acid cannot be used to dry ammonia because they react with the ammonium gas. So the ammonia will react with calcium chloride, forming a complex salt, and a sulfuric acid will react with ammonia, forming ammonium sulfate. Ammonia is less dense than air, and therefore it is collected by upward delivery. Because remember, ammonia and hydrogen gas are the two gases that are completely less dense than air. They are less dense than air, and therefore they can be comfortably be collected by upward delivery. Again, ammonia has only one drying agent. There is only one suitable drying agent among the three common, and that is the only drying agent there will be calcium oxide. So look at that, capture that the drying agent, the method of collection, and the reagent used. And also note about the arrangement of the apparatus, that the round bottomed flask should be slanting downward to prevent the water from condensing and flowing back to the flask, which may cause it to break. We can continue, and we go to the commonly used base is calcium hydroxide because it is cheap, it is readily available. So the same with ammonium chloride, the most commonly used salt because again it is cheap and also readily available as compared to the other salts. So we need to look at the test for ammonia. So how do you test for ammonia? You dip a glass rod into concentrated hydrochloric acid solution and lower it into a gas jar full of ammonia gas. It will form white fumes. You'll be able to see white fumes. So simply we say test for ammonia, you simply expose it to hydrogen chloride gas, and formation of a white fumes indicate presence of ammonia gas. The white fumes are as a result of a reaction between hydrogen chloride gas and ammonia to form ammonium chloride, which appears as a white solid or rather as a white fumes. So it is a white fumes, but on cooling, it is going to form ammonium chloride, which is a white solid. In this kind of a scenario, remember that ammonia is the only alkaline gas under wet chemistry. As far as your syllabus is concerned, the only gas that is alkaline that you're going to interact with is only going to be ammonia. So again, if by any chance you test the gas, you lower, or rather you insert a moist blue or red lithium paper into gas jar full of ammonia, it will change from red to blue. So when you see a gas that turns a red lithium paper blue, then that gas is ammonia because it's the only alkaline gas that we're going to study under the syllabus. But remember, the conventional test for ammonia is that it forms a white fumes, or rather it forms a white solid when reacted with hydrogen chloride gas. So if you are taught to describe the test for ammonia, you say you dip a glass rod in concentrated hydrochloric acid, because concentrated hydrochloric acid will, when you dip a glass rod there, it is highly volatile. It's going to produce hydrogen chloride gas. So when you have the hydrogen chloride gas, then you lower it to a gas jar full of ammonia. The reaction between ammonia and hydrogen chloride gas will form white fumes of ammonium chloride. We continue. The round bottom flask, this is a point to note in the diagram. The round bottomed flask should be slanting downwards, left to right. This is to prevent the water vapor formed from condensing and flowing back, which may crack the flask. Also remember that moist reagents should not be used. and this will dissolve the ammonia gas produced. Looking at this, the diagram that we are using dry reagents, and also the round bottom flask is landing downwards. Very important to capture that. The gas is collected by upward delivery as it is less dense than air. It is less denser than air. The gas is dried by passing through calcium oxide, but not concentrated sulfuric acid or anhydrous calcium chloride. This is because it will react with both concentrated sulfuric acid and calcium chloride. Very important. Remember, the drying agent should never react with the gas. Let's look at the physical properties of ammonia gas. It is a colorless gas. It has a pungent smell. It is less dense than air, and it is highly soluble in water. Hence, a solution of ammonia is prepared using an inverted funnel. So it is highly soluble in water, hence a solution of ammonia is prepared using an inverted funnel. So if you want to have, you have the dry calcium chloride plus ammonium chloride, and you are heating it, you can see the flux is slanting downwards. Then you want to get ammonium, aqueous ammonia. Then you should be able to direct the gas produced into water in a beaker using an inverted funnel. Using an inverted funnel. The role of the inverted funnel is to provide a large surface area for the dissolution of gas, and that prevents the sucking back of the water to the hot flask, which may cause it to crack. So the role of the inverted funnel is to provide a large surface area for the dissolution of the gas, or rather for the gas to dissolve, because it is highly soluble in water. This is to prevent sucking back. A common mistake that you can be asked by the examiner will be identify this apparatus. In many times when you tell students to identify this apparatus, they are going to say this apparatus is called an inverted funnel. That is wrong. We don't have any apparatus that is called an inverted funnel. It's simply a funnel, or rather a filter funnel. So, but when you are told how to describe how to prepare a solution of ammonia, then you direct the gas into water using an inverted funnel. But if you are told to identify which apparatus is this, then the apparatus is simply called a funnel. So the purpose of the inverted funnel is to provide a large surface area for the dissolution of the gas and to prevent sucking back of the water to the hot flask. This inverted funnel is also used to prepare other very soluble gases like hydrogen chloride gas, sulfur 4 oxide, and nitrogen 4 oxide gas. So we look at revision exercise. As students set up the apparatus as shown in this particular diagram. As students set up the apparatus as shown in that particular diagram to prepare and collect dry ammonia gas. Here you have a mixture of ammonium chloride and calcium chloride, moist. Then you are looking at the gas, you're collecting it, pass through a drying agent, and you're collecting by downward delivery. Then you're told, identify 2 mistakes in the setup and give a reason for each mistake. Identify 2 mistakes in the setup and give a reason for each mistake. Let's look at that. Referring to the notes that I've already given you. One is that we said we always use dry reagents. So the use of moist reagents is a mistake. The ammonia gas produced will dissolve. So remember, the examiner has told you to identify the mistake, not the correction. So some students say dry reagent should be used. That is a correction. So here the mistake is use of moist reagent. That is the mistake. The reason is because ammonia is highly soluble and will dissolve. Number two, look at the orientation of the flask. It is slanting upwards. So the mistake is the flask is slanting upwards. The water formed will flow back, causing the round bottom flask to break. So the mistake is the flask is landing upwards. Most of the common mistake that the student that will make will be, or rather most students will make a mistake by saying the flask is not slanting. That is a very wrong statement. First of all, you have talked about, you are giving us the correction, not the mistake. The flask here is landing upwards. The correct position should have been, the flask should have been slanting downward. But for this one, the mistake is the flask is landing upwards. The water formed, the water vapor produced will condense, flow back to the flask, causing it to break. Another mistake is wrong method of gas collection. Rather, collecting ammonia gas by downward delivery is wrong because ammonia is less dense than air. Therefore, it cannot be collected by downward delivery. So the mistake is wrong method of gas collection. Let's look at the answers. I've already given them. The mistake is method of gas collection is wrong. Reason because ammonia is less dense than air. Mistake number two, the flask is slanting upwards. That is the mistake. Not the flask is not slanting, it is the flask is slanting, but it's slanting upwards. Reason the water produced by run back and break the flask. Mistake number three, more reagents should not be used. Rather, more reagents are being used, and reason ammonia gas produced will dissolve. So use of moist reagent. And we have come to the end of our beautiful lesson today. So we have come to the end of our beautiful lesson today. So we are going to stop at that particular moment, and for you to be able to get more of the notes, you can be able to get more of the notes. You can be able to get the top notch book 3, whereby you're going to get smart notes like the one that I've given you, the smart note like the one that I've given you today. So it's going to be able to get a better note from there, so you can get a copy of the top notch books.